This is the presentation for the EEE 6512 Image Processing and Computer Vision class at University of Florida. I'm Shafali Gundecha and I'll be speaking about my project, that is face detection and recognition for phone contact addition. To begin with, I'll give you an overview of what these slides cover. So first we'll be going through the introduction, followed by background and approach, followed by result and analysis of the techniques implemented, and then we'll move on to the conclusion and proposed future work for this project. So introduction. Well, what is this project about? The main goal is to develop an Android application to support contact addition in mobile phones through face detection and recognition. The idea is basically if you walk in at a party or even in a professional setup, you should be able to add people to your contact list without having to enter their details manually or giving each other a call to save the number. With this app, one click the camera should be able to launch, um, detect a face in its field of view, capture the image, and look for it in its database. Um, so basically, once a contact is found in the database, the user will have some options to send a request to add and wait for acceptance of from the other end. Okay, apart from just contact number and name, this app can also have options where the user can add their email ID, their address, their LinkedIn connect, or a link to their Facebook profile. A lot of other options can eventually be integrated. This basically gives the idea of the broader picture of the application and is the motivation to and is the motivation behind this image processing project, the goal of which is to implement the image processing part of the application, that is to implement face detection and recognition techniques and to test their efficiency with standard pre-existing database and a more realistic database that I've created myself. Okay, so to begin with, you'll wonder why do something of this kind. Well, first of all, a picture is worth 1,000 words. If I tell you my name is Shafali over the phone, it's less likely that you'll remember me. But if you meet me in person, there's a greater probability of your remembering me, since your brain can now associate the name with a face. And from science we know that images register better than words. So this application in a way works great, or this option works great for times when you're meeting someone for the first time. Moving on, other reasons, other rather more important reasons to use this app. When you're finding a match in the database, when you find a match in the database and you save the registered contact information, it ensures that the saved information is right. There are no typos, there are no wrong email IDs, or there's no wrong information that is being saved. You have not saved someone's Hotmail ID as a Gmail ID or anything like that. And of course, with a well-built app, this can be faster than a manual addition of manually adding contact information. um, well, you might wonder, if you don't want to enter data manually, why not use a business card or QR codes? One, because business cards can be lost, and also you're not always carrying them around with you, but your face is something that's with you wherever you go. And another reason is that people enjoy clicking pictures and they enjoy being clicked. So why not use image processing for this sort of an application? Having covered what and why, let's look at how are we going to implement something of this sort. As you can see here, the first block is to detect the face. Once a face has been detected, the face needs to be captured, resized, cropped, converted to grayscale, so that the face recognition algorithm can work and look in the database for any match that can be found to what we are searching. And in case a match is found, you can send a contact request. Else, you can have a choice between exiting or researching the database or recapturing another image. And there are many other features that can also be added to this system. um, Moving on to the technical side, face detection. For purposes of face detection, I've used the Haar Cascade detection method. The idea is that a cascade training operation by the idea is that by taking training input as many positive and negative images, which are like by positive I mean many images with faces, and negative is many images without faces. So you give this training data. So it works based on this. The idea is using a cascade of classifiers, you can get rid of unimportant regions of the image in the earlier stages, instead of applying all features to all regions of an image. And thus you're like reducing computation time and improving the detection algorithm's efficiency. Moving on, for face recognition, the Eigenfaces method is implemented. It's based on the principal component analysis technique, wherein when the idea is to identify a subset of uncorrelated variables that hold most of the information. So this work on PCA forms the basis of Eigenfaces algorithm, and it instead of analyzing every pixel of an image, which is a very time consuming, and it's not even required. So instead of doing something like that, this method makes the algorithm extremely efficient. And having said that, let's look at the databases that we cover in this project. The AT&T database, or the ORL database, basically it has 40 database images corresponding to 40 different people, 10 images per person, and they're taken against a dark background and with slight variations. For our case, I've used a subset of this AT&T database where 10 people and 6 images each have been considered. And in the personal database that I created, I have 6 different people with 6 images each, and these images have been captured in front of a white background, and with varying facial expressions and pose and illumination by using torch and flashlight and all of that. And the AT&T database is known to perform well with the eigenface recognition algorithm. Like the algorithm and the database not together, they tend to perform well. So that's why the idea of creating your own database to give it a more realistic database and check how this technique actually works. So moving on to the results and analysis, as we can see here that the first half covers, as you can see here, we'll be covering the face detection part first. As you can see, the algorithm performs very well in decently illuminated images. It fails only for extreme brightness settings, like over here when there's a lot of light in the image, or if the image is really dark, which is this last option here. That's when your algorithm fails. But for every other case, it works really well and is able to detect images that can be viewed in this blue rectangle pretty well, and it also performs multiple face detection efficiently. But since that is not the focus of a project, we'll not go into details of that. Moving on to face recognition, we have results from the AT&T subset database. I ran it for changing a number of images in the gallery. I kept reducing the number of images to see how many images are really required to achieve a good enough percentage of recognition. Here you can see the average image that is used for all recognition runs, and these are the reconstructed images. Most of them get reconstructed pretty well, but some of them not. You give poor reconstructions. Looking at the results, well, the acceptable recognition rates can be observed here. By good, okay, bad images, I mean images that have been taken under good conditions. And by bad is like extremely bad, where there's tilt, there is huge change of facial expression, or there's illumination by the torch, those are bad images. And there's an unexpected increase here that we can see, and this can be attributed to the fact that what happened is that when I went down from 30 images to 20 images in the gallery, something that was earlier reporting as a mismatch, since that got deleted out of the search space when we scaled down the search space, um, the algorithm was able to match it to the correct thing eventually. This in a way actually forms the basis of the research option that the application will have, wherein if you hit research um, of the image in your database, it will like the current match that it reported will be ignored, and it'll look for any other image that matches your thing. So in a way, it kind of increases the probability of finding a correct match. Also, what's interesting to note is these four pictures here, these two sets actually. These were the mismatches reported, and it's interesting to see that a human eye wouldn't have caught this, but this like, because the gender of these people is different, but if you take a closer look, the features are pretty similar, like the eye and the nose and all of that match. So that's an interesting thing to note, and it also tells us that large databases can confuse the algorithm unless more images per person are used. And if you look at this graph, which kind of plots the maximum Euclidean distance for correct recognition, this in a way helps us to set a threshold for our personal database, wherein if it goes above this threshold, it's more likely that it can give a wrong match. So it might as well give a no match found than giving a wrong match. So this from this, like, you can see it's usually in the range of zero point 0.4 to 0.6 something. So for our database, I chose the 0.5 threshold to avoid any erroneous match from being reported. So for in the self-created database, I had 6 different people, 6 images per person, 2 good, 2 bad, 2 okay, and the threshold was set to 0.5. And similar to the AT&T, you have an average image that gets created, and you have reconstructed images which are pretty good for most cases, except a few poor reconstructions. And the results and analysis shows that a low recognition rate is observed, which in a way is also expected, since you have a more realistic database here. You have a lot of variations in your mix of data, and also because the database is so small, a single mismatch drastically reduces the recognition rate. And also the fact that I actually wrote a MATLAB code which crops the entire set of images together and converts it to grayscale. So it's not that so in a way, like, the best cropped image is not taken, it's just a uniformly thing done. And since your camera setup and all is not fixed, um, these images are not tend to lose some information in some cases. So because of these reasons, these rates, like, can be justified. On the whole, the rate is very satisfactory for the conditions under which it was tested, so I'm pretty happy with the results that I got. And to come to the conclusion of this presentation, the face detection and recognition algorithms were successfully implemented. They were Python, OpenCV, and a mix of MATLAB codes were used, and they were tested against the AT&T and a self-created database. And you get average rates of about average recognition rates of 90% for AT&T and 72% for the self-created database, which is kind of okay for now. But as a part of future work, I'd like to work more on the database front, where you have a large set of self-created database, and so that I can aggressively analyze varying image data sets and varying sizes. And from the looks of it, 2 images per individual in the gallery kind of was acceptable, though I know that 7 and 8 is ideal. But if you have to look at it from an application point of view, for the user's convenience, 2 images is also good enough. But I think the future work will shed more light on that side. And if increasing database and adjusting thresholding values and cropping techniques does not work, maybe other recognition techniques can also be looked at in the future. So we'll now move on to the demo part of this presentation. This is the face detection code that is used. OpenCV comes with a trainer as well as a detector, so it makes it very easy to do face detection. Um, it contains many pre-trained classifiers for face, eyes, smile, etc. So we load that classifier, this XML file, then we load the image that is the on which we want to do face detection, and it gets converted to grayscale, and face detection algorithm is run on that, and a rectangle is basically made on this image. They can also be mapped onto the color image, which gets saved as image face detected.jpg. And if we quickly go and run this code, so I'm running this file, and so we had this initially, and now if you refresh, there you go, you have the image face detected file created. And if we go down there and view it, there. So this is what the original image was, and this is the face detection. You can see the blue box has been formed. Moving on to face recognition, this face recognition code has been taken as it is from the code.google.com, the Pyfaces folder that they have there. And so what it basically does is that it uses Eigenfaces. It runs this Python file called Pyfaces demo, which requires as argument input the image that you're going to search against the database that you're going to search, and the number of eigenfaces in that database, and a threshold for acceptable match. Okay, so it first runs this main Python file, which calls for the Eigenfaces Python. This code basically is it has two classes. One is the face bundle class, which initializes all your variables and eigenfaces and average values, all of that. And second part of it is the face recognition class, where actually all the recognition happens. It validates the selected image, so it looks for the correct size. It sees if your height and width everything is matching. Then it actually runs the algorithm to find a match of your image. It does all the calculations to like it calculates the weights and where is that, yeah, and the average value, the subtracted value. So subtract the average value from each of the original values to get your adjusted face, like the ones that we saw during the presentation in the results section. And then you have this you have different functions. So you have the reconstruction function, and you have a function to calculate the Euclidean distance and all of that. And then finally your eigen images and calculated. And this section actually is not of much use right now. It's just some section to cache some data and report some errors or any folder changes or anything of that sort. So this is a script that I wrote to run a probe, like to run rather to probe all the data in the probes folder in one go, and give me all the results in a text file. And I'll just give you a quick demo of how the results look when you do one run. So here, as you can see, I'm running this Pyfaces demo from this folder which has the demo file in it, and I'm probing this image, which basically is this image of mine. and I'm going to probe that against the gallery that we have here, and hopefully it should give me one of the 07 marked images, or the the 07 marked images. So let's see what it returns. And I've set the threshold to 0.5 because anything about that, as we saw, is most likely going to be a mismatch. So run this. Okay, so here you see number of eigenfaces used, that's the value I entered here, and then tries to reconstruct images, and then it reports the time it took, and here is where it tells you the match that it found. It says B07, and this is the Euclidean distance, which is pretty acceptable. It's actually pretty close. So if you see 07 is actually this image, so the recognition in fact works. So that was just a quick demo of the face detection and recognition part, and I hope you liked watching this presentation, and if you have any questions, do let me know, and you can also drop a comment for any suggestions that you have. So here are the references, and thank you for watching.